Hello, welcome to Tech Point Fundamentals YouTube channel. Today we will see what is shadowing in C Sharp, and we will see all the points related to shadowing with a real practical example. So before continuing this video, you are requested to please subscribe to my YouTube channel so that you can get a notification whenever I upload a new video to my YouTube channel. Before continuing this video, I have already created two videos, that is on abstract class and virtual methods, because this point is related to uh, overriding and hiding as well. So I will recommend you to please watch that video. I will provide the link for that video in the description, so please watch that video before continuing this video so that you will get a clear picture what we are discussing in this video. So in C Sharp not only supports method overriding but method hiding also. In C Sharp you can hide the method of a base class from the derived class. This concept is known as method hiding or method shadowing. The term shadowing is normally used in case of VB.NET, but in case of C Sharp we are normally use the term method hiding. So what is shadowing? When two members use the same name, one of them can hide or shadow the other one. Here we are not talking about anything about signature or access modifier for that particular member. What we are talking about here, just only the method name or element name or property name, not about anything related to method or property signature. So if you remember, in case of virtual method or abstract method we are talking about the signature, but here we are not talking about anything related to signature. So this is the main difference between these two. In case of method hiding we are just talking about the name, nothing more than that. So in case of shadowing, by shadowing, the child class can create its own version of the base class method or property, and a method of the base class is available to the child class with a new definition or implementation without using the override keyword, because we are using the override keyword for overriding the base class implementation, right? And if you remember, the new keyword is optional in case of method hiding. If there is a method that is virtual in the base class and in the derived class you are not providing either override or new, in that case it is automatically hide the base class definition. So before continuing the fundamental points and the fundamental rules, we will see all the points with a program, live program. So I have already created a simple console application. So if you see, I have created a simple base class method, and there are a lot of properties and methods, and this base class is inherited in this derived class. And here I have done some method overriding and method hiding, and again this child class is inherited from this derived class. So basically these three classes in this inheritance hierarchy, and this main program I have called each one of this class for accessing all the methods or property which were defined in this class. Okay, so let's start. Overriding redefines only the implementation, not signature, but shadowing redefine the whole element, right? If you remember, in case of method overriding we can only change the implementation, not signature, but in case of method hiding we can redefine the whole thing. Here if you see, this is a property, simple property, and this is a instance variable. So this is the derived class where we have uh, replaced completely these two definitions. If you see here, I have created a method with name count. Here if you see, this is a normal instance variable. Similarly, if you see here, I have created a total method in the derived class, but if you see in this base class, this is a normal property. So I have replaced completely these two elements with the new, and if you see, the type and signature both are completely changed. We have just replaced everything, but this name is same. So this hide the base class elements, and the method signature, access level, and return type of shadowed member can be completely different from the base class member, right? Similarly, if you see some other methods, for example, this show method, here it is a public method, and in the derived class I have made it private. So you can change the definition and signature as well. The shadowed element can be inherited further in the derived class. Okay, the shadowed element will still be hidden in the derived class. So what it is saying, in this class I have hidden these two members, and this display method. Here I have used this new keyword for the display method, and this display method hide the base class display method. And if this derived class is being inherited by someone, this child class, in that case that display method of the base class is still in hidden for this child class as well, because I have hidden this display method by new implementation altogether. So let me run this program so that you can get a clear picture. Here if you see, when we are calling this display method from this child class, right? If you call this display method from child class, the derived class version is called, not the base class version, right? So this child class display method is still hide the base class display method, right? The shadowed element can be inherited further, right? In the derived class, the shadowed element will still be hidden in the derived class. So the hidden member in the derived class is also hidden in this child class. If the shadowing element is inaccessible in the further derived class, shadowing is not inherited. The derived class inherit the original element instead of shadowing element. So in point number 4, what we are saying, that suppose you have provided sorry, a new implementation for a particular base class method. Okay, so in this method, if you see, I have provided a base class print method which is normal method, and in case of not print, this show method, and in the derived class we have marked that member as private. I have hidden the base class show method with access modifier private. Then what will happen when you call this show method from this child class variable? So it will call the base class version, base class show method, instead of this derived class, because it is not accessible to the this child class. If you see in this output, the show method base class version is called, not the derived class. Why? Because this member is inaccessible. This is hiding you know this hides the base class member for this uh, derived class only. And next point, a shadowed member of the base class is available to the child class without the use of override keyword. So there is no not a requirement of putting the override keyword for the hidden member of the base class in this derived class. So for hiding, it is not required to put the keyword override. If you see in this derived class, I have just overridden the member which are virtual in this derived class. In this one, this display method and this print method is off. Because if you see here, I have uh, hidden this print method of the base class by providing the new modifier, and where we are calling the base class print method. If you do not specify either shadows or override, the compiler issue a warning message to help you to be sure which kind of array definition you want to use. If you remember, if there is a member that is virtual in the base class, then in the child class you are not providing any modifier like override or new, then by default compilers hide the base class definition, base class member. On the same time, the compiler generates a warning that whatever you required, please specify either override or new modifier. Base class a high hidden member cannot be accessed only can be accessed only either by base keyword or by creating a base class reference variable. So the points come how if you have shadowed a base class element, then how you can access the base class definition in the child class. So there are three ways to access the base class implementation. One is the base keyword. If you see here, this is the derived class or child class method print. Here I have called the base dot print. So this will call the base class print method. This one here, if you see, base class print method is called. In this output, if you see the derived class, base class print method is called, right, in the derived class. And the second one, if you see in this main method, I have created a base class reference variable pointing to the derived class, right? And if here if you can call every member of the base class, but here is trick here. If the method is hidden, right, in the derived class, then it will call the base class version, not the derived class version. Okay, so if you see base class reference variable pointing to the derived class. In this case, base class display method is called and the derived class overridden display method is called. In this case, it is calling the derived class definition. Why? Because it is overridden, not hidden. So in case of overriding, always the base class reference variable pointing to the derived class always call the base class implementation or definition, not the derived class implementation, not the base class. But in case of method hiding or shadowing, it is reverse, right? And if you see in every part, this is calling the base class definition for print and show, count, base class method implementation is called, because all these members are hidden in the derived class. Similarly, the next, you can also get the base class implementation definition by typecasting the derived class object to base class, right? This is the derived class object, this one, and I have typecast this derived class object to base class so that we can get the base class implementation. So again it will call the same method just like the above, this base class reference variable. This derived class overridden display method is called, and rest of all the base class definition will be called, not the derived class. So these are the three ways to access the base class hidden methods in the derived class. If a element is simply hidden, then the implementation to call is based on the compile time type of argument, that this pointer instead of runtime, like overriding, right? In case of method overriding, compiler have to resolve the which version should be called at runtime. But in case of method hiding, if you see here, there is nothing to do the compiler at runtime, because compiler knows that if method is hidden, then this is the only method which I have to call, so it will not go to find the which version should be called at runtime. So this pointer is used to call this method, hidden method basically. And if a base class method is not overridden in the derived class, it is hiding the base class method, as we are seeing in a lot of program and implementation. If you are not providing the override keyword, then it hides automatically the base class. Shadowing fundamental rules. Both virtual and non-virtual members can be shadowed. In case of method overriding, it is mandatory that the base class member must be virtual for overriding, but it is not mandatory in case of shadowing. The new keyword is optional for hiding. If you do not use the new keyword, the compiler generates the warning. So you can remove this new modifier, for example from this. Then what happens? The compiler generates a warning: hides inherited member base class dot display. To make the current member override that implementation, add the override keyword, otherwise add a new keyword. It is just warning, but if you run the program, it will run and work perfectly, right? So this is how compiler is designed for .NET framework. So basically the .NET framework understand this, that if a developer has missed any keyword, new or override, then what the compiler has to do, right? And the shadowing and method overriding both can be achieved together by using the virtual modifier with the new keyword. You can achieve both at the same time. Here, by providing this new keyword, you are telling that yes, this method will hide the base class display method, right? Again, by providing this virtual, you are saying that yes, this method can be overridden in the derived class which derived from this derived class, right? And if you see, there is a base class method that is print method. If you see, this print method is a normal method in the base class, and in the derived class I have marked that method as virtual with new keyword, means it is hiding the base class print method, and the class which derived from this particular derived class has ability to override this print method. So you can achieve both at the same time. And we can hide base class virtual method by using the new keyword. We can use the new keyword with virtual keyword together. We have seen that in the example. We can use both new and virtual. We cannot use the new and override keyword together because two modifiers have mutually exclusive meaning. What it is saying, that you cannot use new with the override keyword because either a method can be hidden or it can be overridden. So you cannot use both at the same time. If you try to do so, you will get a compile time error, right? A member marked as override cannot be marked as new or virtual. Similarly, you cannot use virtual as well. You cannot use both of the keyword virtual or new. So because either a method can be hidden or overridden, you cannot do both at the same time. But you can use virtual with new, so that this will hide at the same time you are making this virtual, so that the derived class can override this print method. The new implementation will only be available in the child class, not to the base class. So this is a very important point when you learn about overriding and hiding. I have just seen the example. So if you run this program, let me show that example once more. So this is the derived class and this is the base class, right? Then what will happen when you create the derived base class object pointing to the derived class? Means when you create the base class reference variable pointing to the derived class, then if you call this for example display method, right, then which version will be called? So let me see the output. Base class reference variable pointing to the derived class, and you have called this display method. Display method, the base class virtual display method is called, not the derived class. Why? Because you have hidden this member. On the same time, if you accessing a member which is overridden, this display method, see, if you see, the parameterized display method is overridden in the derived class. In that case, if you see, it will call the derived class version, not the base class version. So this is the difference between hidden method or shadowed member and the overridden member. So which version is called? In case of method hiding, the base version will be called. In case of method overriding, the derived class implementation or version is called. In shadowing, a base class reference variable pointing to a child class object will invoke the hidden method in the base class. A base class member can be shadowed to private only if the shadowing definition is not virtual, because a virtual member cannot be private. If you see this example, there is a method that is show method. This show method is public in this base class, and in the derived class I have hidden this base class show method with a private access modifier, right? So you can change the access modifier while you are hiding or shadowing any member, but remember just one thing: you can only mark this member as private only if this method or hiding member is not virtual. Let me close this program, and if you try to make this for example this member, and if you try to make this as a private, then you will get a compile time error. Virtual or abstract member cannot be private. So this point is also conditional when you can make a hidden member as public or private. So this is the rule when you can make a hidden member as public or private. If a shadowing member is defined as private, in that case it will not be inherited further, right? If you see here, this private member will not be inherited into this child class because this is no accessible due to this protection level. And if you run the program, then the inheritance of this shadowing member is defeated. In that case, the compiler resolve any reference to the same element it would have if there had been no shadowing. What will happen if you uh, call this show method with the object of this child class? Let me run the program once again, and if you see this child class, right, and if you see the show method, base class show method is called. Now what happened of this uh, child class, that is derived class, this implementation where this is not inherited into this class, and at the runtime compiler resolve is there any member with the show name, and it will go to this derived class, and in this derived class if it check that this is the new implementation which is private, then it will again go to the base class of this derived class, and if you go to this base class, then it find the show method and it call this statement. So this is the way how compiler works, right? It will call the base class, not the base class. If you suppose there is 10 level of inheritance hierarchy, in that case suppose this show method defined in the second level of inheritance, and each and every there child inheritance hierarchy there is a private member, then it will go to the second level of inheritance and call that particular method and skip the all the child classes below that. So why shadowing? We know, if you see for example, when we miss, if there is a member that is virtual and in the derived class you have missed to, either you have to provide the implementation with override with that virtual member, or if you just retain that virtual method without any modifier like override or new. In that case, compiler automatically hide the base class implementation. So why shadowing? So the main purpose of shadowing is to protect the definition of the base class, or the definition of the class members, right? The base class might undergo a change to create an element or member with the same name as it one you have already defined in the child class. So let suppose here is a method count and total in this derived class, right? And if you see in for example, this derived class is inheriting from this base class, and this base class may undergo a change that he has defined a variable name count, and in this also a property with the name total. So what will happen if this shadowing is not implemented by this .NET framework? Then what happen if you create the object of this derived class? Then which version it should call, this method or this variable? Because we know that by inheriting this base class, these two members also inherited in this derived class, right? This is the inheritance principle. And if you see this in this main method, I have created the base class object. That's fine, not an issue, because these two variables count and total are there. But in case of this derived class, by inheritance principle, we know that we have accessibility of this count and total variable and properties of the base class in this derived class, but it's not true. If you see here, if you try to access that variable, if you print dot and press C, if you see the intelligence, this is only showing the method count method, not the count variable, like this. Why? Because this shadowed the base class element. So that's why this derived class only showing the count method, not the count variable. You cannot access this variable, you have to call this. So this way the compiler, suppose what happen if not shadowing, then this derived class object can access this base class count instance variable instead of the member which this derived class has defined. This method, if this derived class access the base class count variable, then what is the meaning of this method or property which is defined in the derived class? So this way the compiler protects your uh, definition, your class definition from the base class, because in base class there may be any change, and he go and define a member with the same name, then it should not break this derived class implementation or definition or calling. So because this change will only uh, will be in that particular base class object, not this derived class. There will be no disturbance to other inheriting class from this base class if this base class go and change anything in that particular class. So this is the key point for using this shadowing at a large level in this .NET framework. So this is followed by the .NET framework automatically. So types of shadowing, basically there are two types of shadowing in case of C# or VB. So by scope, that means without inheritance, and by inheritance. If you see in this example, for scope I have defined an instance variable name count here, and similarly I have defined again a variable with name count here, then this count variable shadow the global variable count. Here if you check this count, then it will access this count, not this one. So by scoping you can hide the outer scope variable. So this is by scope, and by inheritance we have already seen how you can shadow the element, this element. Again if you see this count method shadow the base class count instance variable, and similarly this total method hides the base class total property. So this is true in case of hiding, but it will not true in case of overriding. So how shadowing is different from overloading? Shadowing is not same as overloading, because only a method or operator can be overloaded, not the properties or variable. If you see, we are hiding total and count. Anyways, count is a variable, and this total is a property. For overloading, the signature must be different, right? And in case of shadowing, it is not mandatory. It can be anything except the name. Name should be same, and everything like access modifier or signature may be changed completely. Similarly, what is the difference between shadowing and overriding? Then it is already a straightforward difference. So just see quickly what is the difference. Shadowing is used to protect against subsequent base class modification, while overriding does polymorphism by defining a different implementation. That's true. We protect the base class subsequent changes, and in case of method overriding, we achieve polymorphism. Shadowing can redefine the entire signature. On the other hand, overriding can redefine only the implementation of a method, not signature. If you see in this example, this count instance variable is hidden by this implementation of this count method. But if you see here, it is a normal instance variable. Here it is a completely a new method. So this is hiding the base class member. And similarly, if in case of overriding, public override void display int number, you cannot change the signature of this display method for overriding, because we are overriding this member. If you try to make this public to private, you will get an error. Cannot change access modifier when overriding, right? So you cannot change anything in signature while overriding. For overriding, the base class member must be declared as virtual, right? That's true. You cannot override a non-virtual member, but it is not true in case of shadowing. In shadowing, we can change the access modifier, while we cannot change the access modifier in case of overriding. You cannot override a method with a property or variable, or vice versa. We have already seen that a method, a variable or a property can be overridden, can be hidden to a method, but it's not true in case of overriding, because you cannot change the signature or type in case of method overriding. the override keyword cannot be used with virtual modifier, while the new keyword can be used with the virtual modifier. That's straightforward. And in the case of shadowing, the base class cannot access the shadowed member in the derived class, while in case of overriding, the base class can access the overridden member in the derived class. So again, I have already seen that example. Base class reference variable if you are creating pointing to derived class, so this display method is overridden in the derived class, so this will call the derived class implementation, while this display method is hidden in the derived class, so this will call the base class implementation, not the derived class. This is the difference. If you see the base class reference variable, then the display method is called the first one, it will call the base class virtual display method, while in the case of this display, because this is uh, overridden in the derived class, so this is calling the derived class implementation, not the base class. So that is the difference in this point. There is no control of a base class on shadowing, right? A base class cannot enforce or prohibit shadowing, but it has control on overriding, right? If you are defining any member as virtual, then uh, the child class can override that particular member, but in case of shadowing you have no control, because a member can be hidden without any change of signature or anything, so the child class is free to hide any of the base class member or element. In overriding, a base class reference variable pointing to a child class object will invoke the overridden member in the derived class, not the base class, while in case of shadowing it will invoke the base class member, not the derived class. So here I have created a simple application. You can go to this article and play around with this example, the same example which we have seen in here. So you can go and check the output of this program. So finally the conclusion, shadowing is very confusing. You have seen that based on different condition it is being inherited to the child class, and which version it will call, and properties or normal instance variable can be hidden to a separate method altogether. So this is the way this make this topic very complex and very confusing. So sometimes it is very dangerous to use, because if you have not used this properly, then it might be possible that it is something wrong if you are not used that properly. Shadowing concept breaks the rule of solid principle. So I will create a video on solid principle very soon. So yes, this also break the solid principle rules. So sometimes shadowing leads to bad coding practice, so use shadowing only when it is required. If you can resolve the problem by overriding, then always go with that instead of shadowing, because if you remember, we are a normal practice if we create the reference variable, base class reference variable pointing to the derived class, but it will work for in case of method overriding, but in case of method hiding it call the base class definition, right? I will also create a separate video on fragile class problem, so it will clear some of the issue between these two. And thanks for watching this video. I hope you have enjoyed this video. Please, if you learn something, if you have learned something from this video, so please like and subscribe to my YouTube channel, and share this video to others as well, so that they can learn this concept as well. So thanks for watching this video.